Uh, uh, in the previous slide, in the previous video, I had shown you the table of all of, I've shown you the big table where you have the number of electrons, number of protons, atomic number, electronic configuration, all this you have seen the table. So now here you are going to see the atomic structure of first 18 elements. So hydrogen atomic number 1, number of electrons 1, helium atomic number 2, number of electrons 2, lithium atomic number 3, 1, 2, first shell, it has got 2 electrons, it is full, it is next third electron is been put in the second shell, L shell. Same way, boron, 2 electrons in the first shell, second shell has 3 electrons, total 5, atomic number is 5. Next we come to oxygen. Oxygen has 2 electrons in the first shell, 6 electrons in the second shell. So the atomic number is 8. Now we come to neon. Neon has 2 electrons in the first shell, 8 electrons in the second shell, L shell. That is, the atomic number is 10. Now we come to sodium. 2 electrons here in the first shell, 8 electrons in the second shell. It is full, so the 11th electron is put in the third shell. Aluminium, first shell has 2 electrons, second shell has 8 electrons, third shell has 3 electrons, 2, 8 and 3. Next one is, I'll show you chlorine. Chlorine atomic number 17, number of electrons 17. First shell, K shell 2 electrons, second shell, L shell has 8 electrons, third shell has 7 electrons. Argon, first shell has 2 electrons, second shell has 8 electrons, third shell has 8 electrons. So that means elements in group 8, the shells are all full, valence shells are full, so they are inert. They have attained stability, so they don't really react with other elements. So this has been explained before. So if you see the structure of these elements, helium, neon, argon, krypton, it goes on. So these three elements, it does not have the tendency to react with other elements. Why? Because its shells are full. Now valency also I have discussed before. Valency is the combining capacity of an element. The electrons present in the outermost shell of an atom are called valence electrons. If an atom's, the number of electrons that you see in the last shell is called valence electrons. If an atom's outermost shell is filled, they are inert. Just now we have explained elements of group 8, helium, neon and argon. They are least reactive and their combining capacity or valency is 0. Of the inert elements, helium atom has 2 electrons in the outermost shell. Atoms of elements have electrons, and the atoms of other elements have 8 electrons in the outermost shell. We have discussed of neon, argon, etc. Atoms having 8 electrons in the outermost shell is having octet configuration and are stable. If an atom's outermost shell is not completely filled, it is not stable. It will try to attain stability. So if it is not complete, it is not stable. So it will try to attain stability either by losing, gaining or sharing electrons with other atoms to attain octet configuration. The number of electrons lost, gained or shared by an atom to attain octet configuration is the combining capacity or the valency of the element. Example, hydrogen, lithium, sodium atoms can easily lose 1 electron because it has got 1 electron in the valence shell, last shell, and become stable. So their valency is 1. Magnesium can easily lose 2 electrons. It has got 12 electrons, 2, 8, 2. It has got 2 electrons in the last shell, so its valency is 2. Aluminium can lose 3 electrons, so its valency is 13, 2, 8, 3, last shell. Carbon has a different number of electrons. It has got 4 electrons. Neither can it give nor can it take. So its valency is 4. It shares electrons with other elements. So its valency is 4. Fluorine can easily gain electrons. Number of electrons in fluorine is 2, 7, 9 electrons are there. So Second shell has 7 electrons. Instead of giving 7 electrons, it gains 1 electron and becomes stable. So the valency is 1. If the valence electrons are more than 4, then 8 minus 5, that will be your valency. So here for fluorine it is 7, so 8 minus 7, 1. Oxygen can easily gain 2 electrons. So oxygen atomic number 8, so 2, 6. So it has to gain 2 electrons. So it gains 2 electrons. So valency is 2. Nitrogen gains 3 electrons because its atomic its valency is 3. So 8 minus 8 its last electron shell has 5 electrons, so it has got the tendency to gain 3 electrons. So the valency is 3. 8 minus 5. Now atomic number. The atomic number of an element is the number of protons or electrons present in the nucleus. Protons or neutrons present in the protons or electrons in the nucleus of the atom. All the atoms of the element have the same atomic number. Hydrogen atomic number 1, helium atomic number 2, that means it has got 2 protons. Lithium atomic number 3 protons. Atomic number, number of protons, number of electrons, they are all same. Mass number is atomic mass. The mass number of an element is the sum of protons and neutrons. The protons and neutrons together is called nucleons, and this is present in the nucleus of an atom. The mass of an atom is mainly the mass of protons and neutrons in the nucleus. So we have learned before in the first slide that electrons have negligible mass, 1 by 2000, but protons and neutrons have is 2000 times heavier. So it sits in the nucleus and it has got the maximum mass. So the mass of an atom is the maximum in the center. Carbon atomic mass 12. 6 protons and 6 neutrons, and it is written as 12U. Atomic mass unit, AMU or U. Aluminium mass number 27. 13 protons and 14 neutrons, and the atomic mass is 27 at AMU or U. Sulfur mass number 32, 16 protons and 16 neutrons, so the mass is 32 AMU. In the notation of an atom, the atomic number and mass number is written as symbol of an element. If you write like symbol of the element, then the mass number, atomic mass will be written on top, atomic number will be written on the down. That is, see for example nitrogen, the symbol is written, you have atomic mass here, your mass number 7 is the atomic number. This is how you represent an element. Now symbol same, contain the symbol of the element, the mass number and the atomic number. This is the symbol of the element. You have the mass number, you have the atomic number. Say for fluorine, how will you write? This is the atomic mass, this is the atomic number. So atomic number, number of electrons, number of protons, same number. Atomic number 9, number of electrons, number of protons 9. Now when you see this number, atomic mass is, top number is atomic mass is 19. So the number of neutrons is 19 minus 9, 10. That is atomic weight minus atomic number.